All right, let's take a look at 9.7, the probability of multiple events. So, lesson preview, we're going to find the probabilities of A and B versus A or B. That's the key phrase here. Are we doing an and problem? Are we doing an or problem? So, vocab, dependent events, independent events, mutually exclusive events. So, warm up to get us started here. I'll do 1, you guys do 2, 3, and 4. We have 24 green, 22 blue, 14 yellow, and 12 red. Suppose you picked a random marble. What's the probability we get a random yellow marble? So there are 14 yellow marbles. There are 24 plus 22 plus 14 plus 12 marbles total. That's 14 out of, what do we got here? 46, 50, 60. Is that 60? 20, 40, 50, 60, 4, 6, 72. So we have 14 out of 72, which will give us a percentage. We can do this. Where's my calculator? There we go. 14 over 72 is, you've got a 19.4% chance of getting a yellow marble. 14 out of 72. All right, try 2, 3, and 4. All right, so we need to figure out what's the difference between a dependent and an independent event. And so when the outcome of one event has no output, does not affect the second event, we are independent. All right, when one is separate from the other, we are independent. When the first one affects the second one, we're dependent. All right, so let's take a look at these. If I roll a number cube and then toss a coin, the number cube has nothing to do with the outcome of the coin, so these are going to be independent. If I pick a flower from a garden and then pick another flower from the same garden, picking the first flower affects how many flowers are left for me to pick. So this is dependent, since the first event, the flower, affects the second event, the second flower. So see if you can do number 1 here. Tell me, are we dependent or are we independent? All right, so if we're independent events, if the first does not affect the second and we want to do both of them, we're going to multiply the two probabilities. Okay, so let's take a look at this. What's the probability that if we call in a radio station and we pick a song, they're going to let our song be the one that goes on the air? Well, they're picking 4 callers every hour. If we call in at 7 a.m., we have a 4 out of 125 chance. If we call in at 3, we have a 4 out of 200 chance. Now, does calling in at 7 affect calling in at 3? No, they're totally separate. So we're going to multiply these two things together and get 4 over 125 times 4 over 200 and get a very, very small percentage. Let's times it by 100 so we can get the percent. 0.064% chance that we're going to be selected both times. Okay, pretty unlikely we'll get selected for 7 o'clock, and there's that keyword and, so we're multiplying, and for the 3 o'clock hour. All right, with those numbers there, see if you can answer 2A and B. All right, so new vocab, mutually exclusive. So mutually exclusive, can we happen at the same time or not? Okay, if we can't happen at the same time, we're mutually exclusive. So when we roll a die, can we roll a 2 and a 3 at the same time? Okay, no, we cannot roll them at the same time, so they're mutually exclusive. Can we roll an even number or a multiple 3 at the same time? Sure. If we rolled the number 6, we rolled an even, and we rolled a multiple of 3. So even, multiple 3, not mutually exclusive, because both could happen at the same time. So tell me if A and B are mutually exclusive or not. So here's our formula. If we want one thing or the other to happen, we add them up. And if they can happen at the same time, we need to subtract any double ups, any repeats. And I'll explain that when we do the example. So let's look at the first example. We're not going to have any repeats here. 53% of U.S. college students are under 25. 21% are over 34. What's the probability that you're either Under 25 or over 34. Can you be under 25 and over 34 at the same time? No, you cannot. Those are mutually exclusive, so we're going to add these together. 53 plus 21%, 74% of the population is either under 25 or over 34. So, see if you can answer understanding check number 4. Alright, last example here. If you're not mutually exclusive, you need to subtract the repeats. So, we reach into this bowl of fruit, this one right here, and select a piece of fruit. What's the probability that we either have an apple or green? So, we look at the apples. There are 1, 2, 3, 4, 5 apples out of 9 pieces of fruit. There are, erase these and come up. Come on, eraser. There we go. How many are green? I see 1, 2, 3 things that are green. Okay. But did we repeat any times? Yes, the apples that are green got counted in both spots. They got counted for the apples. They also got counted as being green, so we can't count them twice. So we need to subtract out 2 of those. The other way to think about this is, how many apples are there? There's 5. How many more pieces of fruit are green that we haven't already counted? That would just be 1 more, right? 3 minus 2 would be just 1 more piece of fruit that is not, that's green, that's not an apple. So that's 6 over 9 total. 2/3 chance. We got a 2 out of 3 chance of getting either an apple or a green piece of fruit. All right, wrap things up. Tell me the probability you're either apple or red. You're either green or citrus. Citrus is a lemon or a lime. And your job here is done. Questions? I'll see you in class.